make TiDB a sidecar to AWS Aurora to make so you can do some real-time OLAP query instead of Aurora using TiDB. Okay. Previously, we have this is just like I mentioned. This is our third episode. Previously, we have a brief introduction of TiDB, and the last previous episode we show how to deploy and benchmark TiDB on AWS, and all of these series episodes you can view on YouTube or Vimeo. First of all, I want to do a quick introduction of myself. My name is Ed. I'm the co-founder and the CTO of Pinkcat, and I'm also the co-founder of TiDB, this distributed transactional SQL database. And this is my email. And if you have any following questions, just feel free to send to me or contact me on Twitter. This is my Twitter account, Twitter handle. So today I'm going to do the quick introduction of why we want to do this, and then I will leave some time for the live demo to create the TiDB as the active slave of your Aurora master. But first of all, why? AWS is a really popular cloud-native database provided by AWS, and also, AWS is very good for the OLTP workload. It is kind of like the drop-in replacement for your MySQL, RDS, and it can support some the scale out. It can still keep your Aurora still keep your MySQL dialect, so your application can, if you have already depends on MySQL, you can just migrate to Aurora without changing single line of code. But on the other hand, Aurora is designed for OLTP, but the OLTP on the OLAP side, it is not very good. Because some AWS Aurora is still using the MySQL code base, we have already known that MySQL is not the OLAP database. So we in the old days we have to put all the in production database the data into another data warehouse like Teradata, like Greenplum or Redshift, something like that, just to do the OLAP query. But if it would be cool if you do some, we can do some lightweight OLAP request directly on the transactional database, because sometimes your OLAP query will not be very complicated. Just something like join one or two table, do some group by with some index. For example, a lot of SaaS company have a feature that every tenant will have their own dashboard. There's some report. There's some analytical thing on your dashboard of each tenant. For these features, it is not simple OLTP query. This feature requires some complicated join or group by, but it will be cool if. But it is also the online service, so it will be cool if you can do such query on your in production database. But in the old days, what AWS told you, you can run your analytical workload on the read-only replica, but MySQL doesn't do the great job in the OLAP side. So if we have some query like this, it is a little bit complicated, and that will be slow on your read replica of your Aurora read replica. So it is it's not gonna work. And if and in the old days, the only ways we can handle such workload is through the ETL. So AWS provides some tools like AWS Glue to make sure the data do the ETL transformation and load it into the Redshift, and do the batch processing to go through the EMR, and using something like Amazon QuickSight. But introducing another platform or another ETL process will be very the maintenance cost. It is really hard to deploy, maintain, and on the other hand, the Redshift or something like QuickInsight cannot provide the online service for your application. It is it is something like the offline data warehouse. So that's not gonna work. And what's more, if your in production database, like you have a sharding middleware on top of your Aurora, and the sharding, the MySQL sharding, you choose some sharding key. In this case, the sharding key is invoice ID. So after the sharding, the data will be on different MySQL or Aurora instance, and that make it even that make it impossible for some architecture like this. You cannot just run your analytical workload on the read-only replica of one shard, because sometimes the shard you have to do some cross-shard join or cross-shard group by, something like this. So we need another solution. Yeah, and from AWS documentation, the document tells you, hey, if you want to do such thing, you have to do the data preprocessor, use EMR, use S3 to do the ETL. EMR, and this is the EMR ETL, and output to S3, and post processor, and dump the data into the analytical thing. Sometimes we just want to do some simple join on two small tables in your database, but you have to deploy the whole bunch of things to make it happen. Yeah, so it is the common pain point according to our observation of the deploy adapter of TiDB. So in this case, TiDB may help. So this is our today's topic. We can deploy TiDB as a sidecar to consolidate the different Aurora instance and put all the data into TiDB, and TiDB will create the real-time synchronization with your Aurora instance, so that you can directly run some read-only or OLAP query on your TiDB, and still keep your OLTP workload on your Aurora with the help of DM. Wait, what is DM? TiDB is a database. TiDB can act as the active slave or active replica of MySQL or Aurora, but with the help of DM. DM is I will have a quick introduction of DM. DM is short for TiDB Data Migration Tool. It is open source, and it is an integrated data synchronization platform. not only for the incremental data migration, but also with the full table migration from MySQL, MariaDB, and of course Aurora MySQL into TiDB. Underneath, it is really straightforward because the DM will listen to the bin log of the upstream MySQL and use the bin log to replay on downstream TiDB. And you can also deploy multiple DM worker to synchronize different MySQL instance and send the data to one large TiDB cluster. And DM is also a distributed system because sometimes you may have hundreds of MySQL instances. We want to do the high availability and we want to know how many workers all of them are working right now. So it is a master and worker architecture. Then DM master is kind of like the metadata, the controller of all the worker. The worker is the process who do the real synchronization job. And we also provide a CLI tool called DM control. DMCTL is a command line tool. It provides a user-friendly, interactive CLI interface for you to control all the workflow. And this is the documentation of DM, and this is the GitHub repo of DM. And basically, DM can use as it's just like the bridge of MySQL upstream MySQL or Aurora to the downstream TiDB or another MySQL. So what's more, the DM can do something like table consolidation. For example, you have already sharded your database, your schema into multiple shards, something like this, table 1, table 2, but it is just a sharded table. And using DM can consolidate all these sharded table into one large table inside TiDB, so that you can run some analytical query. You can consider TiDB is a large database. You just send the join, the group by, the complicated OLAP query just on TiDB, and that will, yes, this is what DM can do. Okay. So let's begin the demo. Today we are going to show how to make AWS Aurora synchronize the data with TiDB through the DM. So our demo is that the first thing is I want to import some data of something like TPCH sample data to my Aurora, and I will launch an empty TiDB, and we can use DM to first load all the data of the TPCH database to TiDB and create a real-time pipeline, synchronize the change log, the bin log, and apply to TiDB cluster. So to make it simple, I will launch EC2, and I will launch DM master, DM worker, and the TiDB instance in the same node, and synchronize the data of one Aurora master. And basically, in production, you can deploy the DM master or DM worker any machine you want. You don't have to deploy all the components in one physical node. So in today's demo, I will launch all these things in one EC2 instance. So let's begin. Before the demo, there is a little checklist to make sure your Aurora is ready to sync sync data to your TiDB. And the first thing is we have to enable the bin log for Aurora. This is the documentation about how to open the bin log for Aurora. And another thing is that you have to enable your GTID option is enabled. And this is also the documentation of the GTID thing. And another tip is you have to make sure DM can connect to AWS Aurora master. Because by default, maybe there's some security groups of some, the firewall thing. You cannot connect to the Aurora instance. And because AWS have some customized syntax, so DM cannot understand what are these. So we have to put some ignore checking items like dump privilege, replication privilege. These are something that TiDB cannot support. So we should ignore this statement. And I also put the example task definition in this gist. So let's take a look. That you can see, put the ignore checking items here, and the task name is test. And the most important thing is the target database. You can put the downstream TiDB or another MySQL instance, the host, the port, the username, and the password here. And another important thing is here, the my dumper. You can see I add the extra arguments here. This arguments is for my dumper. And this parameter is the database name of the upstream database. Basically, it is what you want to synchronize, what's the DB you want to synchronize. Yeah, pretty simple, right? So let's take a look at the Aurora. This is my console dashboard of my Aurora. You can see I have Aurora writer and the reader. For example, in the checklist, I said we have to enable the bin log. The configuration is in the DB cluster parameter group. I have a customized parameter group called bin log open. Basically, it is just, let's see, the bin log format here. By default, it's not row, so you have to set it to row format. And another thing is GTID. You can see the GTID mode is on, so that means we have already enabled the GTID. Okay, let's see. This is my EC2 instance. So I will deploy the TiDB, the DM worker, DM master in this node. Okay,
Let's go to the EC2 node here. Okay. So to make it simple, I have already deployed TiDB instance in this local machine. It's pretty simple. It's a single node mode. Yeah, here. Yeah, you can see I have already downloaded the DM binary here. This is the table of the DM. Basically, you can follow the install guide of DM project inside in the README page. Here, this section. Today I'm going to deploy the DM manually. So, but for the in production deployment, I recommended you to use the Ansible to deploy the DM. But today we are going to use the manual deployment. Okay. Yeah, you can see I have already downloaded the DM. Let's take a look at the configuration directory here. You can see the DM master, DM worker, DM control. This is a CLI2. My dumper. It is okay. Let's take a look at the configuration directory. You can see, let's take a look at the DM worker. You can notice that the DM worker is the worker who is in charge of synchronize data. So the DM worker have to connect to the upstream Aurora. So you can see in the configuration file of DM worker, you can see, the from. This section is for the upstream Aurora instance. You may notice that the password here is encrypted. It is encrypted by the DM control. DM control. Basically, it is. Let's take a look at the example. Encrypt. For example, my Aurora instance, the password is hello world. And use this command line to can generate encoded password, so you don't have to put a password in plain text in the configuration file for the security consideration. Okay, let's take a look at the task. Basically, it is just the task configuration in the gist in the gist file I list here. So a task is that means synchronization job. The most important thing is the downstream database definition. So in our case, the downstream database is localhost because I launch a TiDB in the local machine. So it is localhost. The port is 4000, the default port. Okay. And ignore checking items just for Aurora. So let's take a look at here. The database I want to dump is TPCH001. This is so you can see this is I connect to my Aurora. You can see we have a example database here, the TPCH001.
They have their own programming, they have their own people coming in to work with their team, but
So you can notice that there's some table in this DB. So let's make sure that downstream TiDB doesn't have such data. Sure. Yeah. Okay. You can notice that we don't have a TPCH001 this DB here. So let's sync the data. The first thing is launch a DM worker.
And we'll show you kind of other space down here as well. We have some support so many of our companies are early stage so maybe like and so they have a membership called
PM worker. That's the parameter.
We want Ray to be able to code a neural network. We're talking about Ray knowing the difference.
This is the parameter to specify the configuration file. So in our case is
the mail
and then we can launch the DM master. Yeah, you can see the DM master. We can specify the lesson address of DM master here, master address. And the deploy section is for specified DM worker. In our case, our DM worker is deployed in the localhost 8262 port. So it's well configured. So DM master. Okay. Yeah, you can see the DM worker and DM master are both alive, so we can use DM control. DM control, you can only specify the master address to connect to the DM master. In our case, is 8261. Okay. Yeah. The DM control will provide you an interactive CLI environment to control the task and see how things going, the job status, the task status. Yeah, okay. Okay. Yeah, you can see our worker here. No task started. You can see we have a lot of control commands. So don't forget, we want to synchronize the TPCH001 to the downstream TiDB. So you can see here, start task. Start task, the parameter for start task, you can see the configuration file here. Basically, it is the task, the YAML file we just created here. Yeah, you can see the task name is test, and the target database is 4000. Okay. Okay. Yeah. So we have a new task here. Oh. Okay. I think. Oh, there's something wrong because the debugger cannot find the my dump binary. It's not a big deal. Let's take a look at the config file. Oh, yeah, I think it's because I launched the DM worker just on the bin directory, so we should use the relative path name here. Okay, I think it's okay. Okay, we just restarted the task. Yeah, okay. You can see that right now the full table dump is on progress. 62%. Okay, the full table dump is successfully finished. Let's take a look at, yeah, you can see the dump stream TiDB have a new TPCH DB and can use this DB. Let's check if the data is the same with the upstream Aurora. Yeah, you can see the data is the same here. So that means we have successfully created a synchronization pipeline with the TiDB and Aurora. And we can run some complicated TPCH query on TiDB side. For example, this is some sample TPCH query, something like this. Basically, because I deploy a single node TiDB in a very weak machine, it is the tiny virtual machine of AWS. So the performance is not very good, but if you deploy the TiDB in the production, this query will be very fast. So yeah, and this queries happen in the TiDB side. It is not affected the Aurora. So that means, and what if we have some change in the Aurora side? Let's take a look. For example, we have 1,500 customers. Yeah, and we also have this data in the downstream TiDB. And we try to insert one more. Let's take a look. Yeah, this line of SQL means we select one row from the customer table and insert to this table. Okay, and right now we have 1,501. Yeah, you can see the data is successfully synchronized to the downstream. So this is all I want to demo today. Thank you very much.